Hello, hello everyone. Let's start with another MATLAB program. So, how are you all? So, first of all, we are going to do with the linear convolution. What's the difference between the linear and the circular convolution? If we talk about the theoretical, then you will say too much difficult task. But if you talk about the simple work, then you will say it's a simply linear convolution is simply about tabular method, and the circular convolution is about taking two in the circle and then moving one, rotating and the clockwise, and then after multiplying checking out, and then later on the additions. So there is a difference only of the related to basically just related to the number of the n sequence, how much in the sequence how much number we will get. If it's a linear convolution, there surely there will be the L1 plus L2 minus 1, and if it's a circular convolution, then basically for that 5 we will get around 4, around 5. Okay, because it will give you the maximum only circular convolution. In this it will give you it's the addition of the length of the both sequence minus 1. So here we have the program. It's a same similar program overall, just one of the word is used, convolution. That's only new in this. But other codes and all the other similar. Oh, here we are. So I had this few errors before, but I corrected it. Now let's write a first sequence 1 2 3 4. I had taken the sequence, first sequence of the length L1 4, and the second sequence of the length also 4, 6 7 8 9. Okay, so after uh, entering the origin sequence is basically showing the 0 of x-axis, negative on the positive side. That's so after convolution, as you can see, we had gotten the 4 1 2 3 4 5 6 7 7. Okay, so both of the sequence are the 4 and 4, and we are getting output 7. So 4 plus 4 8, and the 1 minus can at the end of the day so 7. So that's why we have the in the linear convolution sequence have the 7 in the output, x1 x2, and the final is our convoluted sequence. So as you know, if you they are the two sequence you are doing convolution in the time domain, then the frequency domain it will be only multiplication and like that. So further on, when we move to the our circular convolution, here we go. So the in the circular convolution, basically what we will do, wait on, let me tell you the basic. Yeah, so if we talk about the basic is like multiplying each term of the second convolution, second sequence, each term with the first sequence, and then uh, in the multiplication what we do, we put the cross at the end term. We will put at the front. First same, second one cross, then third two cross, then and then later on we add, such as we done in the multiplication, but just basic little bit differences with that. So let's start. So here we have the max n1 n2. It's basically, as I had already told you, that the length we have taken for the output convolution is should be the maximum from n1 and n2. Which one is maximum? We will take that one only. Here further on we had done our statements, if else statements for statement is used for the mathematical work, and later on we will represent our title for the plottings: first sequence plot, second sequence plot, third, and the final sequence of our output sequence, or the we can say circular convolution sequence plotting, and the labeling of each one, and all are represented in the single plot. So we will write 1 2 3. Okay, so for the later on, it's till yet there is a representation and the basic work only using the, it's used up to the, there are the two method is used. First is the module operator, they using if else or for statement. Other way of the circular convolution is using the inbuilt function. Inbuilt function, it's a predefined keyword of the MATLAB, such as cconv, c c o n v, matlab means circular convolution. We use directly our inputs and the n value of our for our output, and we will give it to the our c conv brackets me, and then further on we will get our output y. So then we will, what we will do, we will stem, because it's a discrete function for the plotting we will use, then we will display by using disp function y, and then we will give it a title to our graph, and is it's 2 axis, so we will give the labeling to our x-axis, to our y-axis, and then we will run it by using run command. After uh, using the run command, then we will move to our command window, and when we move to our command window, it's scrolled above, sorry. So then we will write our first sequence. So there is a mistake, we need to use our brackets before writing this. So this type of the mistakes will happen with many, so don't do these mistakes. Always use the capital letter, sorry, bracket. Always use the bracket before and after. And then we have taken our first sequence 1 2 3 4 5, second sequence 5 6 7 8. Okay, so here we have our both sequence. As we know, our first sequence has a length 4, second sequence also length 4, so the maximum length will be 4. So our output sequence will have the 4 terms as it's showing for the circular convolution. Okay, now let's move further. Checks the graph, discrete graphs of this circular convolution. When we check these graphs, we can clearly see there is a first sequence, its amplitude and then samples are shown, then there is a second sequence, then there is a circular convolution by using the module operator. We use the if else for statements twice and all that, and the other one is using inbuilt function, the keyword, predefined keyword in this